Okay, and I am sharing the screen as well. Okay, so good morning. Okay, so I think I have shared my screen and it is visible to all, and my voice is also audible. In case of any problem, do let me know via WhatsApp group. And yesterday, what we saw, how data science is related with IoT, and we realized that the most important thing is data processing. And yesterday we saw one advertising data set in which we do multivariant linear regression analysis. And today also we'll continue with the topic of data processing. And today I'm going to demonstrate some important most conceptual things which we usually encounter during data processing. So let's jump to the Jupyter file. So I am having a folder of files for HTTP, which is folder name, and it is on desktop, and I've got my all work here. So I'm creating a new file here, and just let me rename it object. So today what I'm going to start is one important data type that is called object data type. And this is one conceptual topic. This is one tricky data type which we usually encounter during uh, cleaning of data and processing of data. So let's jump to this thing and see how to deal with this object data type and what it is. So let me import. I think screen is visible to all. In case of any problem, do let me know, please. Import pandas as PD. Okay, and now I have got one. I'm today I'm starting with Excel file. Yesterday it was CSV file. Today I'm starting with Excel file. So I've got one Excel file with me. PD dot read underscore. In case of Excel file, you need to write here Excel. In case of CSV, you need to write CSV. Now I'm reading the Excel file, and the name of file, it is stored in the folder on desktop. Its name is sales underscore cleanup. Sales underscore cleanup, and then you have to write the extension. In case of CSV, you write .csv. Here you write XLSX. XLSX, and then you just need to shift enter, run this thing. So and df. So this is a very small file actually. I want to show you how to deal with object data type and all. So I'm using this file just to demonstrate this thing. Now at this point, I need to tell you one thing. In some earlier versions of pandas, this Excel file will not support. So what you need to do, you need to pass here one more argument that is called engine equal to OpenPy Excel. Engine equal to OpenPy Excel. This thing has been introduced recently because this Excel file creates some problem while opening in some other type of OS other than Windows. If you are opening it in Mac or it in Linux, then this Excel file may create some sort of problem. That's why this new parameter has been introduced recently. So if I run this, it will work okay, no problem. Without this, it will also work. But suppose in your system, if this Excel file is not working, then you need to do this thing. And suppose if this OpenPy Excel is also not working, then you need to just install it. Here you can install it by pip install openpyxl. Openpyxl. Just run this thing, and now it is already installed in the system, so it will show you that requirement already satisfied and all that. If it is not installed, then it will just install it, and then you need to install one more package, that is pip install diffused XML. Pip install diffused XML. This has already been installed, so again there will not be any problem. This is just optional. In case if it is not running, then you need to check this thing also. Otherwise, I hope this Excel file will run okay. This Excel extension will run well, okay. Now let's jump into this file and see what it is. So there are two columns, one is customer and one is sales. And let's just do some info, df.info. So we have seen this info thing earlier. It will provide me some data related. So there are 6 entries only. This is a very small data set. There are 6 entries starting from 0 up to 5. You can see here also 0 up to 5. There are only 6 entries. And there are 2 columns only. One is customer and one is sales. And non-null, there is a non-null entry here. And this is the object data type. Now this is not integer, it is not float. Already you can see here, this is float, but it is showing that it is object. This is also integer, and this is string because there is a $sign here. Overall, what is happening? Pandas is treating this as an object. So before proceeding, before dealing with this object data type, what you need to understand, what is this object actually? So let me define you this thing for you. Object means that a string is stored, but this is superficial definition. You must understand this thing that you can create a series of lists or dictionaries or integers, tuples, anything within this object. In other words, Python objects are stored in pandas series, and pandas basically store a reference to that object and call it the type object. Actually, what is happening? This is calling it data type as object, but it is not only a string. It can be anything. It can be a collection of lists. It can be a collection of dictionaries. Basically, it is just acting like a pointer. It is pointing to something else where more number of data types are stored. And pandas, for simplicity, overall consider this as an object. So object columns are reference to other columns, and pandas.info runs fast and it doesn't go deep into it and look for the object that how much memory they actually need. Hence, it prints out memory usage with plus sign. So whenever you will see that there is an object data type within this, you will see that this memory usage, here it is always a plus sign. Whereas if there is an integer data type only or float data type only or a string data type only, in most cases you won't see this plus sign, because now what is happening? This is memory usage. This is the least memory that it is taking, 112 bytes plus, because info is not going deep into this object referencing how much this reference pointer is taking, how much memory this reference pointer object is taking. So let's see in brief how to just see how much memory these object things are taking. So before diving into deep how to deal with this object thing, just brief. In a brief, I want to show you how you can check how much overall or total memory this data set is having, this taking in memory. So for that, what we'll do, df.info, and in info, you need to pass one parameter, this memory usage. This memory usage equal to deep. So what I'm doing, I am diving deep into this data frame of this Excel sheet, and I am seeing how much memory usage is being taken. So now if I run this, it will give me the total memory usage, and it is 436 bytes. So this is 436 byte. Earlier it was showing 112 bytes plus, because it was not looking deep into what object data type is actually storing. Now when I am forcing it to go deep and check, then it is showing that okay, the overall memory usage is 436 byte. Similarly, what we can do, similarly we can also check out individual columns. So just let's check out how much these columns are taking memory. So for that, what we can do, df, that is the name of the data frame that I'm using, memory usage and empty parenthesis, and let's run this. So it is showing that customer ID is taking 24, sales ID is using 24 KB, and index is using 64 kilobytes of memory. But still it is not showing the overall, because it is not going still in going, because I'm not using deep here. So it is showing me the superficial usage of memory. It's not going deep into it. So what we'll do, we'll just go deep by writing deep equal to true. And now it is showing me that customer is using 224 kilobytes of memory. Sales is using 148 kilobytes of memory. And if you see, I'm using the dot notation. So I can use here series convention of concatenating operators. So let me do the sum operation also. So now it is showing that overall the memory usage is 436, and you see here overall the memory usage is 436 bytes. So the overall theme of this thing is that while dealing with object data type, you must remember that these object data types are consuming more memory usage. Okay, and now the question is uh, how we can overcome this situation, how we can manage this memory usage to keep low. So I'll come into that with another data set, because this data set is very small and it will not justify the purpose. Uh, Here I want to show you what is the problem with this object data type. And after that, I'll again come with this memory usage with another data set having some large value. And there we will see how to use this object data type to save our memory now. Okay, so again, leaving this memory usage part here for some time. Now I'm coming back to this object data type, and we are going to explore this thing. So let's explore this sales column. Now there are two columns here. One is customer, another one is sales. So let's see what this sales column has within it. This is the sales column. Let's see what this is. So I will write here df, and then I can use dot sales dot apply, and I want to check the type of this sales column entries. I'm not checking the type of sales column. I'm checking the type of entries inside sales column. So if you see here, there are 6 entries. The first one is an integer. The second one is a string. Third is float. Class is a string again, then integer, then integer. And if you check this sales column, it will give you, okay, see, you can just compare this thing here. First is integer 500, then it is a string because it is a dollar sign here, then it is a float decimal point here, then again a string, a dollar sign, then integer, then integer. And overall this data type is an object. It is not integer, it is not a string only, it is not float only. So it means that the object data type has got everything within it. And that's why pandas treat it as object. Okay. Uh, this nicely shows the issue. The apply type code runs the type function on each value in the column. And as you can see, some of the values are floats, some are integers, some are string, and overall this is an object. Yesterday we saw advertising data set, a complete machine learning model, and there was very little use of Python, direct use of Python. Although everything was indirectly Python, but there was direct use of Python was very less. Now we see here some direct use of Python functions. So I want to just format my data set here. So what I'll do, I'll use a df and then my sales column, and I am just adding one more column in my data set. So my column is sales. Let me here rename it. I want to add sales type or data type, you can say sales data type in my sales column. So I'm using one method of Python that is called lambda. Lambda, you must have heard about lambda. It is just anonymous function which do not return. You don't need to write return and you don't need to write def. So it is an anonymous function x. I am applying this type of x, and what are the type of x here? You see the type is integer, string, float, string, integer. So I need to write these names. I need to write integer, string, float. So what I'll do, I'll write the name. So you have to use double underscore name, double underscore type of x, name the type of x, apply it to x, and apply this function to sales data type column, add it in sales data type column, and then print df. So now you see, this is not necessary step. This is just I'm formatting my data to make it more clear. It will help me to understand, okay, what type of data it is, data type it is. So this overall, this sales is an object data type, and what I'm doing, I'm just adding another column. It will help me to understand, okay, this 500 is integer, this 1000 is a string, this is float, and like that. And if you don't want to use this thing, then there is another way. So let's see also that df, what I'll say, dot sales. Now I am showing you how you can use the bracket notation as well as dot notation. You can use both things. Whenever you are adding some new column, then prefer bracket notation. Otherwise, this dot notation is good, no problem. So what I'm doing, df dot sales dot apply. I'm applying just like previous. Apply type, and there is one more thing, one more way you can check your data. Value counts. I want to check what is the count of each value. So I'm writing value counts, and if I run this, so it will give me that in sales column, I am checking the type and I am giving what is the count of each type. So it is showing that there are 3 integers, there are 2 strings, there is 1 float. So all these are only a better way to visualize your data, to analyze your data. These are not necessary things you don't need to do. But whenever there is an object type, then I just above show you, it affects your memory usage. So it's always better to analyze these object types. Okay. So if you see that now the sales column is stored as an object, presence of dollar and comma. They are not treat. They are helping the sales column to not treat them as numeric values. So more than likely, let's convert it into some numeric value. Can I convert my entire data type into something? Can I convert now? This is string, this is float. Can I convert everything as a float? So let's check this thing. df dot sales. If somehow I convert everything as an integer or float, then my work is done actually of saving memory. So what I am doing, I am converting the sales column as type say float. And if you see this, it will throw an error. Could not convert a string to float. Okay, so this dollar sign is creating problem. So this method fails actually. I cannot convert everything as an integer or float. So let's do some other thing. What I prefer now, I prefer something which is my favorite. Now it is I'm using dot notation, so I can use series operations here. So let me use. I'm using a string operation, so I'll write string r dot replace. So what I'll do, I'll replace the dollar sign with nothing, with a space. So let me replace the dollar sign with blank space. And since this is a series operation, I can still use dot replace in continuation, and any blank space if I have, then also I need to replace that with nothing. So this is dot replace operation, and let's run this. Okay, so now dollar has been removed, but somehow I am getting nan, which is not a number function here. Now this is again problem. This is something which I had wanted, I hadn't expected also. The string values were cleaned up, but the other values were turned into nan. It means that even I can't use this operation also. So what I'll do, I'll use now regular expression. So let's use regular expression here. So what I'll do, sales equal to df sales, okay, and then dot replace, but this replace will now be done with the help of regular expression, and backslash dollar. So I am replacing the dollar sign with nothing, but now I'm using this with the help of regular expression. And then what I'll do, I'll replace the comma. If there is comma also, like this, there is a comma. Let me replace this comma also with nothing. And I have to pass one parameter that regex regular expression is equal to true. Okay. And then I'll pass it that as type float. And now let's run this thing, df sales. Let's invalid syntax, where it is. Replace, okay, I need this thing to replace, okay, here. It is acting as key value pair. So let me just pass brackets, curly braces. I'm making it like a key value pair. If it finds a dollar sign, then its value will be empty space. If the key is comma, then its value will be empty space. And this is since format of dictionary, so I have to pass this thing within curly braces. Now you see, now everything is crystal clear here. Now I have converted my object data type into this float. Now this data type is float. Can I check now? Okay, so here it is sales column. You can see it has been converted into float. Earlier it was object, but now I have converted this sales column into float. So what will happen now? This will help me to save my memory. Obviously, yes, but actually here I have added another column, sales.data type. It is still object, so that's why it is showing more memory. Okay, moving on. There is another way to write these things. I hope I am clear. Is there any doubt, any query? Then please let me know. Okay, moving on. Let's check. There are more ways you can use these things. If you don't know regular expression or you are not comfortable with these things, then let's create another way to show you. I'm writing a function here. The function name is def clean. Clean x. What I'll do, if I'm using if is instance. This is if is instance x comma str, and then what I'll do, return x dot replace. So what I was doing here, let me copy paste this. Okay, copy paste this entire thing. Control C V. Just place it x. So I'm again replacing the x. If x is instance of a string, if x is instance of a string, then replace any dollar sign within this x with blank, and replace any space with this thing also, and then just return my x, return x, and will it work? Okay, so function is clear. And now what I'll do, I'll just make the changes in columns, sales and equal to data sales dot apply clean, that is the name of functions. I'm using the function here, and as type float. This is just another way. Sorry, as type dot is at wrong place. As type sorry, data df. Okay, so it's working. Now it is the same thing. This is the thing. Df sales dot replace, and in case you are not comfortable with this thing, you are more comfortable with this thing, then what you can do, you can just create a function here using the earlier dot replace one liner. You can create a function like this, and you can use that function now here instead of using that regex equal to true and all. um, let's check df. It should work like that only. Df dot head. Okay, so you can see here it's working. Okay, now it has been converted. Data type, actually this is another column. I'm not using this data type, so I haven't changed anything within this data type, so it is just as it is. You can also convert now this sales data type entry. So let's just convert this thing also. Df sales data type. This is the column name, sales data type. Okay. Sales data type equal to in sales. Okay. Sales dot apply lambda uh, x and type. It is just previous one which we have typed. Now what it will do, it will overwrite, because now I have changed the sales column. So now I'm changing the name for my sales type column. I think it will work. Okay, now see. So now it is just overwriting the previous statement. Earlier it was a string int float because it were a string int float. And now again, if I run that statement, you see now it has all been converted into float. So it has been converted into float. So this is how you can deal with object data type. Because the real problem with object data type is memory usage. It consumes a lots of memory. Okay, this is one way you can handle the object data types. Now there is one more way with which you can handle the data type, and that brings you to another conceptual topic that is called categorical data type. Before proceeding, let me just check if there is any problem. I hope my voice is clear and I'm getting. I don't have got any problem with the screen sharing also. Okay. Okay. So another thing is that you can convert your data type into another data type that is called categorical data type. And this categorical data type is one very important, very useful, very conceptual topic. So what we'll do, we'll create one new file and we'll start with another data set which has got some huge values, and then I'll show you how to use this categorical data set in data processing. So let me just create one more file. So we can close this thing. What is it? Okay, then. So this is now we are going to start categorical data. Okay, so this is categorical data type. We are going to start with categorical data type. So let's import the function first. Import pandas as PD. Okay, and now I am using another data set. I have stored it in my folder. Let's start using it. It is drinks equal to pd dot read CSV file. It is a CSV file, and its name is drinks dot CSV. Drinks. Okay. Okay. Let me change the name of this drinks because every time I have to write drinks. BF, and let's run this again. BF. Now this dataset drinks.csv is available on kaggle.com, and there is one more way with which you can fetch this thing. Let me show you also. df1 equal to pd. Actually, I'm not going to use this df1 anywhere. Just it's to show you. pd.read csv bracket. You can pass URL here, http colon bit.ly slash drinks by country. Drinks by country. No, df1. Okay. So you can use this thing also. So I have got this data set in my folder on my local machine, so I can just write drinks.csv here. It is available on Kaggle. You can download it from there. I'll provide this CSV file in the WhatsApp group later. Or if you want, if you don't want to download, just you want to do the analysis part, then you can just pass it to http.bit.ly drinks by country link. It is a GitHub link of a very good data scientist, Kevin Markham. He has provided it in his GitHub account. You can just download it from there also. This is how you can just fetch your data onto pandas. And now let's use the information. Okay, So this is a big data set, not very big enough, but big data set to understand the categorical data type concept. I have got 193 entries, 0 from 192, and this data set is showing the alcohol consumption of each country. There are 193 entries, and this is showing alcohol consumption of each country from every continent. So this is a very large data set. See a beer serving, spirit serving, wine servings, total liter of pure alcohol. Here it is country, and here are the continents also. Actually, I've got I will increase the screen font. That's why. So here it is. Okay. So let's do the memory analysis. If you see the data type, this is end, this is end, this is end, this is float. There are two objects. Okay. So this is country and this is continent. Memory usage, you can see this is 7.6 plus KB. And now let's use the memory usage part here and see how you have to analyze this object data type, when you have to change this to categorical data type, and when you should not change this. So let's jump into this thing. df.info. Again, just I show you message usage here, memory usage equal to deep. Now you see the total data set is 19.9 KB of memory usage taking, and it is 7.6 plus KB earlier it was showing. So now it has driven some deep into this object data type, fetch the original memory size. These objects are also storing within themselves, and the overall data type is 19.9 KB. Now what I'll do, again, let's see how much memory usage every column is using. So df dot, what I'll do, memory usage. Okay, so you can see here country is using 772 kilobytes. Actually, I am just interested in my country and continent, because rest are int and float and all. These two are objects. So I am interested in analyzing these two columns. One is country, another is continent. So let's write df dot memory usage. Again, it is not showing the full memory size because I haven't forced pandas info to go in deep. Now I'm using memory usage to go deep. Deep equal to true, and see. Now, earlier the country was showing 772, continent was showing 772. When I dive deep into this memory usage, see here, this is 71846982, these much of bytes. If I sum this thing here, so this is approximately 20 kilobytes, which is 19.9. It is approximately 20 kilobytes. Okay, so now let's analyze this continent and country data type of object and see how we can convert them into categorical data type. So I'm starting with continent data type, and what I need to check first before converting my object data type into category data type, what I need to check, how many number of unique values are there. Let me write this thing here. How many numbers of unique values are present in object data type column. Now, this is the most important thing you must check before converting your object data type into categorical data type. So let's check this thing. For first, I'm checking for continent. So df dot continent. I think this is the spelling of continent. C is small. I just be double check that case sensitivity issues don't occur. Now I'm using unique function. Let's check this thing. Okay. So you see 1, 2, 3, 4, 5, 6. So there are 6 unique values. It means that although there are 193 entries, but there are only 6 unique values, means these values are only repeating. These values are only repeating itself uh, to add up to 193 values in continent column. Okay. We can sort this thing also. Control C, Control V, put it in bracket and sorted. So now it has been sorted in alphabetical order. Okay. Now what we will do, uh, let's check the unique value for country also. And you can see that there are 193 unique values of country. It means that Afghanistan is written at first place, and later in 192 entries, there is no Afghanistan being repeated. Every country is individually written. Every country is unique. None of the country has been repeated even once in the entire data set. There are 6 continents. They have been repeated to form 193 entries. There are 193 countries and none has been repeated. Okay. So let's now convert my continent column into category column. And how to do that? I'll use def continent. Let me check here. Def continent equal to df dot continent, and I am converting it as type category. Okay. So let's run this thing. It's working. Okay. Now df df dot info. Okay, now you see here, this continent has been converted into category data type. And you see memory 7.2 plus. Earlier it was something 7.6. Some reduction has been done. 7.6 plus KB. Okay, earlier it was 7.6. Now it has become 7.2 plus KB. Okay. Now what is happening here? What is this category data type doing? If you see, this category data type is simply creating a lookup table. It is creating a lookup table for my continent column, and it is just saving the results of my continent column in form of integer. It is saving the continent column contents in form of integer. And suppose first one is Africa, so it will give a value 1. For example, it can give any value. It is giving a value 1 to the continent Africa. So every time Africa will come, 1 will be used in place of Africa. So in place of a string, now category, what a category has done, it has provided a lookup table, and this lookup table will point to that value. And in category, there is one option that you can check what lookup table values has been assigned to each column value. So let me write one thing, that df dot what I can say, df dot continent. Let me check the first 5 values of continent column. So df dot continent dot head. Head is used to check first 5 values. So see here. Now you see this is categories. Okay, 6 categories are there. 0, 1, 2, 3, 4, 5. Asia, Europe, Africa, Europe, Africa. There are 6 categories: Africa, Asia, Europe, North America, Oceania, South America. Okay. Now what I will show you, I will show you what code has been assigned to these 6 values. So let me write here df dot continent dot cat means category. What codes have been assigned, and I want to see the first 5 values. Now see, these are the first 5 values only. Okay, I'm not showing the entire 193 values here. If you will remove this thing, you will get the entire 193 values. So I'm just using first 5 values. The first country belongs to Asia, second country belongs to Europe, because if you see here, first country is Afghanistan, it belongs to Asia, Albania belongs to Europe, Algeria belongs to Europe, and like that only. Okay, so now if I run this, see here, what is happening now? Now this 0 has been assigned a value 1, and this 1 is the lookup table value. This 1 is pointing to Asia. This 2 is pointing to Europe. So what is happening? The category data type has converted my object data type into integers. It has stored the values. It has stored the values in some lookup table, and every time when I need to call Africa, this 2 will point to that Africa, this 0 will point to that Europe, 1 is point to Asia. Let's check the memory usage now. df dot memory usage, and deep equal to true. Okay, now you see here this continent. Earlier, what was the value of this continent? Before it was deep memory usage. Yes. Here, continent was, okay, I just, okay, earlier continent was 772. Okay, I rerun that. That's why it is now showing 512. If I just start it from beginning, let me just run this thing again. The memory usage 772, again go much deep. So it was 6928. Okay, 6928 bytes. Okay, now what I am doing, I am converting this thing. So what will happen now? Let's check this thing. Okay. It was something 6000 bytes. Now it has become 512 bytes. Okay, so what I have done, let me write here what is happening here. Instead of, I can say that instead of storing 193 strings, instead of storing 193 strings, now we are storing 193 integers which are pointing to, I can say that now I am storing 193 integers, and these integers are pointing to a lookup table, pointing to a lookup table of 6 string values. What are those 6 string values? Here they are. The 6 string values are Africa, Asia, Europe, North America, Oceania, South Africa, America. So what is happening now? Instead of storing 193 strings, now we are storing 193 integers. And these integers are pointing to a lookup table of 6 string values. That's why it has just reduces the memory usage of continent. So this is one way you can handle the object data type by converting them into category type. Now let's apply the same things on this country data type and see what happens here. So df country, and what I'll do, I'll convert this into category. So df dot country dot as type, and what is the type? The type is category. Okay, and let's check for df dot info. So a country has been also converted into category. We are done with my continent part. It is converted. It has just everything got. Now here you see what is happening. When I converted continent, let's do one more thing. Okay. When I converted the continent into category 512. Okay. Now I have converted the country into category. You can see the memory usage has increased. Earlier it was 7.6. Now it has become 10.5. Okay. Let's do the coding part also. Let's see what are the lookup table values assigned here. So df.country.cat.codes, and let's run this. Now you see here what is happening. If I copy this line, what will I write? Copy, and let me paste this thing here. Control V. Now what is happening? Instead of storing 193 strings, now we are storing 193 integers, which are pointing to a lookup table of 193 string values. Because we saw earlier that in case of country, there are 193 unique values. Okay. So instead of reducing the memory usage, it has now increased the memory usage. If you check df dot memory usage, and deep equal to true. See here, it was something 9,000 and now it has increased up to 10,000 bytes. Why? Because earlier it was pointing directly. Now I have created a lookup table of 193 integers. They are taking their memory. These 193 integers are pointing to 193 string values, which earlier it was pointing to only 6 string values. And then they are storing as 193 strings. So instead of reducing the memory usage has been increased. So again, what is the moral here? What is the moral? You can say that you need to convert your object data type into categorical data type when the unique values are very less. In continent case, the unique values were 6. In country case, the unique values were 193. I am converting 193 values of continent into 6 unique values, 6 integers. Here in country, I am converting 193 unique values into 193 integer values. That's why the memory usage in case of country has been increased, but in case of continent, it was decreased. So I think you understand when to use category, when to convert, data object data type into categorical data type. This is very important thing. This is how this category data type and object data type is very confusing part uh, when you go deep into data science. Like I am also aspiring data scientist, so I learned these things. I thought let me just introduce with this part of object and category data type, because this is very confusing. It is often readily asked in interviews, because they also know that nobody go deep into these things. Superficial knowledge. Okay, object means a string. It is not integer. It is not float. But what is the purpose of this object? So let's go deep dive into it, and when to convert this object into category data type, when you should not convert object into category data type. Okay, so this was the second part of today's lecture, which I wanted to share with you. First was object. What is object? How you can deal with object data type? What is the problem with object data type? And second, I wanted to show you the categorical data type. When you can use categorical data type, when you should not use categorical data type. And again, when you will dive deep into this category data type, it is also a very vast topic. Um, so I'll leave you at this point only for category data type, because I wanted to just give you a brief introduction of memory usage, object versus category, when you should use, when you should not use. Now I will start with where I left yesterday, that data processing, how data processing is done in machine learning part. So these two things which we learned today are also important in case of memory usage with object handling. So let's create another file now. I think this is done. I'll provide with you drinks.csv, and I'll also provide with you the sales underscore cleanup Excel file. Although there were only 6 entries, but it is good to use that. So let's close this thing now. Let's start with another file. Now I'm starting with the famous iris dataset. You must have worked on iris dataset numerous times. There are numerous lectures, tutorials available on iris dataset. Let's see if something new comes out of this lecture. Okay. If anybody, yes, there is a problem. If let me check the WhatsApp group also. I think if there is any question, you can just unmute yourself and ask, please. If at this point, or you can type it in WhatsApp, or you can
Yeah,
just
hello.
WhatsApp me personally. Even I can see. At this point, I think there is no problem. We can proceed
Yeah,
further.
hello.
Yes, sir.
Yeah, Abhishek sir, I have a query. You said about the memory uses.
Yes, sir.
What type of memory will be occupied by the programs in a computer? Which memory? In which location they will store?
Uh, okay. Let me show you. Let me check. Let me check if I have got something in my system for that to show. Okay, so if you say actual memory location, actual memory location is used in just like when you bought a computer, the ROM uses the programming memory. And if you are using the programs here, if you are writing the programs here, then it is used by RAM. If you are saving it, then it is used by RAM, it is used by EPROM, it is used by ROM. So actual hardware memory is utilized. And if I want to just show you one thing, A is equal to 100, and when you type print ID, there is one function in Python that is called ID. And if you run this, so this A is stored in memory, and this is the address of that memory location. This is the memory ID of that memory location, which is used in computer. This A is a black box. It is pointing to a value 100, and where it is stored in the memory, it has got some memory address. So using this ID, you can use this memory location here. You can check the memory location, and this is the actual memory location used inside your computer where this A has been stored. And what happens when you pass this A equal to 101? Okay. And let me just write it here. Control X, Control V, print ID A. See, the memory location has been changed. Now what is happening? Earlier you had passed a constant value 100. You have stored a 100 value to this variable A. You check for that memory location, and then you overwrite this A with another value 101. And this memory location is now left blank. It has got this 100, but there is no variable pointing to this 100. And this is the thing in memory which you call garbage collection, because now this 100 has become what you can say orphan. This has become orphan. There is no caretaker, no variable taking care of this constant value 100, because now I have assigned this to some another memory location 101. So this is called garbage location, and these all are actual memory addresses. And Python, one advantage of Python is called automatic memory management. So it deals with these dynamic memory locations, garbage collection things equally. So the question was which memory location, actual memory location of your computer is being used in every case when you store something. Okay. Uh,
Yeah.
so
Thank
I
you.
think,
Thank you. Thank you.
okay.
Yeah.
Okay. Let's move with the iris data set. Let's just remove this thing. Okay. So iris data set is one of the most common data set which we have been using since we think of starting data science. This is the first data set which we generally encounter with when we start with dealing with data science thing. So let's just call the libraries first. Import numpy as np import. Now, pardon for the speed, because I'm not a computer science guy. My typing speed is not that fast. From scale dot datasets dot sorry, import load iris. Now here I want to just show you two things. How to call this iris dataset. Now there is one way. This iris dataset is so old, so famous that scikit-learn has just saved this thing into their dataset. So if you write from sklearn, that is scikit-learn dot dataset, just import this load iris. So this is one way. Now I write iris equal to this. Iris is the variable name iris. Let's do just don't get confused with it. I write df equal to. I will write load iris, and then I run this df. Okay, so this is one way you can call this iris data set. So this is just showing the values, and if I print the type of this df, it will show you that this load iris belongs to class called bunch, and this bunch class is similar to dictionary. It means that it has keys and it has values. So what I can type here, I can type def.keys, and when I run this, so it will provide the keys. The keys are data, the keys are target, frame, target names, description, feature name, file name. So from here, I can straight away check what are the feature names. df.feature names. So the feature names are, there are 4 columns: sepal length, sepal width, petal length, petal width. Now this iris data set is nothing, it is a collection of flowers. There are 3 categories of flowers, and they belongs to target. So if I call target names, because here I have a key called target names. So if I write target names, so there are 3 flowers: setosa, versicolor, virginica. 3 categories of flowers. One is setosa, one is versicolor, one is virginica. So this is one way with which you can fetch your data set here. Another way is that store your data set iris, like df1 equal to, I've got the iris set data set is stored here. Pd dot read csv, and iris dot csv. Okay, and let me just check df1. Okay, so here you can see sepal length centimeter. Okay, sepal width centimeter, petal length centimeter, petal width centimeter, and species. So these are the columns. Now this is the data set that is available on Kaggle, GitHub, and whoever have uploaded it, they have changed the column name according to their convenience. Like it is in centimeters, so sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter. If you are using this thing from sklearn dataset, then you see here the column names are written like this. Okay, so no problem. You just need to see which way you are using the dataset. I use both the dataset, both the formats. If I use df.info and I run this thing, and then it will show you an error, key error info. So in case if you are using load iris from dataset directly, then the certain things of pandas won't work on this thing. df.info won't work. If I write df1.info, let's see, so it will work like normal. So again, just be familiar with one thing, then jump onto the another thing. See, if you are using data set and you are applying that info method and all that, then maybe it won't work. It will throw an error like this. So when what is the need of the situation? Just use that. Okay. So at present, I am using this iris this way. I am using this load iris way. Just I wanted to show you that you can use like this also. Now, what is the advantage of using this load iris way? With this load iris way, the scikit-learn data set has already provided you with your capital X and small y, that is your features and your response variables. you created a feature column of TV, radio, and newspaper. Then you created a target column of sales. But here, if you are using the direct data set, target names are already done and feature names are also already done. You just need to provide these things to X and Y variables directly. So that's why for the demonstration purpose, I'm using this thing for the time moment. That is DF, not DF1. But I think the purpose which I wanted to show you is clear. So I can use X equal to df dot data. Okay. Now this data is the inbuilt data type that is provided here. This is not the data that I usually use as a variable name. This is the data of dictionary keys. Okay, so if you are using load iris, then you can directly use this df dot data, and this df dot data, it will be assigned to capital X, or it will become my feature column. Similarly, y is equal to df dot target. Again, I haven't named anything as data or target. When you use this thing, then target is also a dictionary key in load iris. If you are using this iris.csv, then you have to define a target variable as a species, and you have to define a data variable as sepal length, sepal width, petal length, petal width. So do remember this thing. Let's print the shape now. Print x dot shape and print y dot shape. Again, it is always advisable to check the shapes because dimensions of matrices matter, otherwise it will just throw an error. We have seen the features name and we have seen the target name earlier, so we can directly use that thing now. Okay, let's move on. Let's see one more thing. Print df dot data. So we have assigned this df.data to X. Let's see what is this df.data. So the df.data is all the rows. So there are all the rows here of 150 cross 4 columns. So you can see here. Now this is sepal length, sepal width, petal length, petal width. Okay. So this is data. And target is not included in this data part. That's why the species column is not being shown here. So if you want to see the species column, so just write df dot target. I'll show you target. Okay, so this is the species column of Setosa, virginica, and what is the name? The names are quite okay. Setosa, versicolor, and virginica. Now, 0 means Setosa, it is pointing to Setosa. 1 means it is pointing to versicolor, and 2 means it is pointing to virginica. One more important thing here, I want to mention that you can see the output is discrete. It is not continuous. It is not 0 0.5, 1.2, 2.7. This is straight away 0 or 1 or 2. When this thing happens, then you can just feel free to remember that this category is belonging to classification, not regression. So this data set belongs to classification type because the output is discrete. So if the output is continuous, then it belongs to regression type. Okay. So let's check one more thing. I want to check df dot species. Okay, one more thing. Species spelling is okay. Df dot species dot value counts. How many numbers of Setosa are there? How many numbers of versicolor are there? How many numbers of virginica are there? species. Species is use the bracket notation then. So, value counts df species not value counts. Is there any problem? Just let me check once. Df species value counts. What I can write here. Df species dot value counts. It's working correctly. Okay, let me just run this once more. DFs. Is it working correctly? It's working correctly. Why not? SPESIES spelling is right. Okay. Target names species. Okay, wait. DF dot target I should have. Names. If I just want to show you one thing, this is again a problem with this load iris thing. I want to show you DF1. Let's run this DF1 thing. I think it will work. Okay. So again, value counts was not working correctly with load iris, but DF1 that we have created, load iris from local machine. I wanted to show you what is the value of Setosa numbers, what is Virginica, what is versicolor, and you see all are 50. Okay, so do remember that when your target, now species is my target, for some reason it was not working with load iris, but it is working with DF1. DF1 means the way I have this one. I have fetched the data from my local machine. Okay, so this when this target has equal amount of values for every class. Okay, Setosa, Virginica, versicolor, all are 50. Then why I wrote this, I wanted to show you this thing. This is called balanced data sheet. This is called balanced data set. When your all values of the target species are of equal number, then you call it balanced data sheet. Otherwise, it belongs to category of imbalanced data sheet. Okay. Okay. So let's move on. Now, what I'll do, I'll just start using some machine learning model. So from, let's type the library sklearn dot neighbors. Sklearn dot neighbors import. I'm using KNN, K neighbors classifier. K neighbors classifier. Okay, and let's run this. It's everything. Okay. And now just create an instance. Like yesterday, we wrote LINREG, lin-reg equal to linear regression. So here I am using KNN equal to this K neighbors classifier. Control C, Control V, and with this you need to pass how many number of neighbors you want to check. So I want to check for n neighbors equal to 1, and in a while I'm just going to show you what this thing means. Knn, then I'll fit, and I've got x comma y. Let's run this thing first. Okay, so it's working, no problem. Now what I will do, let's predict. Let's do the prediction part. So what I'm predicting, knn dot predict, and in bracket, now you have to remember that pass two square brackets. I'm passing 3 comma 5 comma 4 comma 2. Now what it is doing, here it is. See here, if you see the inputs here, if you see the here inputs, these are the inputs. It means that what it is saying, 5.1 is the sepal length, 3.5 is the sepal width, 1.4 is the petal length, and 0.2 is the petal width. Then this flower, if the flower leaf sizes are this, sepal length is this, sepal width is this, petal length is this, petal width is this, then it belongs to Setosa class. This is the meaning of this data set. Similarly, the researcher person has done this for this much entry. Okay, so if I jump to the last one, it is 5.9, 3.0, 5.1, 1.8. Then it belongs to number 2. And what is number 2? Number 2 is Virginica. Okay. Now what I am doing, I am creating a k-neighbor classifier. I am assigning it with value of x and y, where x is the data, y is the target. Now I am assigning a new random value, 3, 5, 4, 2. 3 is the sepal length, 5 is the sepal width, 4 is the petal length, 2 is the petal width. And I want my machine to give me output to which class this length and width flower belongs to. And if you see, this 3542 is not present in this data set. Okay, this is 150 cross 4, and in this entire 150 cross 4 table, there are no 3542 written like this, like 3542. But 3 is there, 5 is there, somewhere if you see 4 is there also, and if you see somewhere 2 you will also found 2 somewhere. Like here, 2 is also there. Okay, and let's run this thing now. Let's run this thing now. Let's run this thing. Save. So it is giving me an output 2, and this output 2 means if the sepal length, sepal width belongs to this category, then this flower belongs to the number 2, that is versicolor or virginica. I always forget that. It is virginica. Okay. So this is one thing, and similarly, you can also pass more than 2 variables, more than 2 entries. Now I want to check what belongs to 5, 4, 3, 2. And if I run this, so it is saying that if this is the dimension, then it belongs to virginica. If these are the dimensions, then it belongs to versicolor category. Okay, what now? Just jump to this point for time being. This is n neighbors equal to 1. What is this n neighbor classifier doing actually? So let's jump to the PPT that I was using yesterday. Okay, I think it is visible. So we were here last class. Now what is happening here? Data is coming. The data is nothing but raw bananas and ripe bananas. So the data is coming in a very linear manner. Raw bananas are getting collected at one point. Ripened bananas are getting collected at some other point. So this is very, very linear data. And now when a ripe banana arrives here, so the machine learning model just check it whether it belongs to this category or this category. Now this according to the graph position, like here some X, here some Y. So this ripe banana arrives here. Fortunately, this is just a fortunate case for me. Fortunately, this banana belongs to this category. This is the decision boundary line, and my machine model just decided that okay, it belongs to ripe banana categories. Okay, so you can see here these are the case. What are the parameters that I am checking here? Whether the texture of banana is soft or it is very yellow or less yellow or is less soft, because the raw bananas are somewhat hard in their texture and ripe bananas are somewhat soft in their textures. So if it is more soft, it is very yellow, then it belongs to ripe bananas. If it is less yellow, means more green, and it is less soft, means more hard, then it belongs to raw banana category. And fortunately, the data which my sensors are sending me, they are in some order that I am getting the linear graph here, linear decision boundary. So it's very okay. And again, suppose an unknown entry comes. If that unknown entry belongs to this category, it belongs to this part of the graph, then automatically what my KNN, what I did, I just pass here, let me show you. What I did, I passed here n neighbors equal to 1. And when this unknown entry comes, the KNN checked for immediate near neighbor, first neighbor. And the first neighbor was 1. Okay, the first neighbor, there it is green color. So it immediately showed that, okay, this belongs to raw banana category. Similarly, when some entry come here, it checked for the immediate neighbor. Only one neighbor I am checking. So who was very close to that? So this yellow color was much closer to that. So immediately the machine model took it as ripe banana category. Okay. But obviously, there can be more complex scenarios, which in real life we deal with these kind of situations. Now, data is coming from sensors in much random order. Now, if I suppose this was the black dot, I want to check which category it belongs to. If I will take n neighbor equal to 1, then automatically my machine will check that, okay, it belongs to ripe banana categories. Although it was not ripe, it was raw, but machine took it as a ripe banana category. Okay. If you see here, the decision boundary is now more complicated here. It is not that much linear. So what happens if my machine categorize this green color as ripe banana, or if it categorize this yellow color as raw banana, then it is called misclassification of data. So every time our purpose as a data scientist is to minimize this misclassification. So every time if you take n neighbors equal to 1, the chances of that misclassification may increase in case of complex data set. Okay, so what we are doing here, we are taking the n neighbors equal to 1. So every time this 3 is coming, 5 is coming, 4 is coming, 2 is coming, what is happening? It is checking, okay, is this 3 where it belongs? The nearest neighbor is, who is nearest neighbor? The nearest neighbor is 3.1, or the nearest neighbor is 6. Okay, so according to that, it is deciding. I don't know, nobody knows whether this is correct or not, because who will give this answer? Machine. Machine is predicting it, machine is giving the answer. As a data scientist, our role is to make my machine more accurate. Obviously, it can't be 100% true, but what is the role? Our role is to make that machine more accurate. So let's check this for another And the number of, let's increase the number of neighbors and see what is happening. Suppose 5 is my number of neighbors, and let's do one more thing. Let me take one more data set here. Control C, and then we will do this thing. Let me write this x new equal to, and copy paste this thing, and just the brackets. Okay, and now is it okay? Okay, now what I am doing, I am training my data on the earlier data set. Okay, this is X, capital X, this is small y. So I'm training my data on the actual data set that we had got with n neighbors 5. N neighbors 5 means now it will, when it has to check this green dot, then it will check for nearest 5 neighbors, not one neighbor. Similarly, if it has to check this yellow dot, it will check for 5 neighbors, not one. Okay, and let's do this. Okay, it's done. And now let's predict on this new data set. Okay, the new data set. The new data set means I am checking for this new x new. Okay, so what I'll do, knn predict, but on new data set, knn dot predict x new. Let's see what happens. Okay, now you see, now if I increase the number of nearest neighbors from 1 to 5, earlier it was 2 1, now it has changed to 1 1. Okay, so which is correct? Again, we can check this which is correct. Let's use one more algorithm. So yesterday we saw linear regression. This is k neighbors. Let's see for logistic regression also. So from sklearn dot linear model import logistic regression. I think this is the library. I am using the right library. Okay, it's working. Now, what is the beauty of this scikit-learn? That you just need to change these libraries names, and every time almost the format is same. And here I wrote linreg equal to linear regression, then I wrote knn equal to k neighbors classification. Now I'm writing logreg equal to logistic regression. So an instance has been created. Again, what I need to do, I need to pass logreg dot fit and x comma y. Okay, I am training on my original data, but I'll predict from the new data. Logreg whether the correction, whether the prediction is right or wrong. Predict x new. Now let's run this thing and see what's happening. Okay, so now the answer is 0 0. It means that both the classes, both these dimensions of flowers, leaves, are pointing that both these new species are what? Setosa. And I want to show you one thing here. You will see an error, not error, but warning here. This warning is that LBFGS failed to converge. Okay, total number of iterations reached limit. Actually, this is the issue with logistic regression. When the data set is not very large, actually this is a very small data set, and logistic regression is just failing to converge this. So to avoid this thing, what you can do, you can write here one thing that check for maximum iteration equal to, say, some larger values. And actually the data set is 150, so let's set this to 400. Now this warning will remove. And again, this LVFGS warning, you can search it on net. That is a very vast issue, but it is warning only, so there is no problem. But I have read in some article that if this warning comes, then don't use this logistic regression. I have read it somewhere. I don't know whether it is correct or not. But okay, let's do with this thing. No problem. Now what I will check. Let's check which is correct. How much I have checked with KNN, N neighbors 1, N neighbors 5. I have checked with logistic regression, and all are showing different answers. So let's check with one at least. So y predict, I am checking whatever I predicted, is it right or wrong? So log reg dot predict, what I'm predicting? I'm predicting for x, okay, and then let's print the length also. So we will just check that, okay, uh, we are everything is being checked or not. There should be 150 entries. Means I am checking for y prediction when it is predicting, whether it is predicting everything or not. It is checking from everything or not. And then I am printing. Let's print metrics. Again, I need to import one library, metrics dot accuracy score. Okay. So it will give me in percentage how much percentage I am predicting or my machine is predicting right or wrong. Y predict. Okay, and now this metric. So let me just import this thing first from scale metrics, import accuracy score. I think again I am writing correct. Okay, let's run this. Some error. What is the error? Matrix is not defined. Okay, let me check. Matrix is not defined. Okay, let me define this thing. From skill matrix. I hope this will. Okay, so first you need to import the matrix, then you need to import the accuracy score, which is a parameter inside that matrix library. So what I'm checking the accuracy score. So it is running on the entire 150 observations, and then you see the answer. It is my observation using this log reg predict is almost 97.33% accurate. Okay, now if you see this thing, I was discussing this thing earlier yesterday. If you see this, x equal to df dot data, y equal to df dot target. I have got 150 entries, and on that 150 entries here, I am not splitting my data. Okay, I haven't used that trained test split model here. On this entire 150 data, I am checking for my feature, and on this entire 150 data, I am checking for my target. I'm not using the training testing model. So when the model is trained and tested on the same data, it is known as training accuracy. Okay, when the model is training and testing on the same data. Yesterday what we did, or what everybody says, that split your data and then do the training part on some part, leave the other part untouched, and after training test on that untouched part, then you will get more better results. So the theme is that maybe I'm getting 97.3% accuracy, but maybe it is not the correct result. Because what is happening? what is happening actually? This is 3. Now my machine knows that it is 3. Every time it is 3, it is 3 because it is training on this data only. Okay. If I split it from somewhere here, I am training 3. Now my machine don't know what is 3 here. So that will give more better result even though maybe the percentage may be less. Okay. So this is called training accuracy. So the question arises: what is the value of k that we should choose in k neighbors classifier? Why I choose 1 or why I choose 5? Okay. With 5, I haven't run this. Okay, with 5, let's run this thing with 5 also. Let's quickly run this thing with 5 and see what is happening. Where it is, this one. Control C, Control V, and let's predict y predict equal to kn dot predict and x, and then let's print matrix dot accuracy. Let's score and y comma y. Okay, now it's using n neighbors 5, it is showing 96%, and using n neighbors 1, it is showing 100%. So um, uh, new person can be very impressed with your machine. Okay, now it's giving 100% result. It means that this raw banana is not raw, it is ripe. It belongs to ripe category. So whether it is right or wrong, it depends on our judgment. Okay. Now let's do the training and testing splitting part. Let's see how to do that. So what I'll do, I'll now just split the model because it is obvious that this training accuracy is not good. From display line dot model selection import train test split. Okay. From model selection import train test split. Okay, I think that's right. Okay, it's right. Now let's write this thing x train x test y train y test. Let's see if it's getting. Okay, x train y x test y train y test, and let's train test split train test split and x comma y comma random state equal to anything other than 0, random state equal to say 1. And again test size will be decided automatically. I'm not giving it anything. And let's copy paste this thing. Control C, Control V. Okay, k neighbors, let me choose 5. KNN fit. Now I don't need to write xy because now I have splitted my x and y. So I'll write here x train and y train. Then in prediction also I need to predict for x test. Earlier I was predicting on the entire set. Now I've splitted it for x test. Here also y predict and y test. Now let's run this thing. So it's showing 100%. Again, whether it is right or wrong, the final judgment will be decided by the data scientist. For 1, let's check this thing for 1. Control C, Control V, 1.0. Okay. Let's check for some test size also. Size equal to say 30%. I'm assigning 30% data to be used as test size and remaining 70% to be used as training size. Now this is 97%. Okay, so here also let's do the same thing. Test size equal to 0.30, 97%. So for me, if I was the data scientist, for me 97% is more accurate result than 1%. No problem, both are approximately same. And can we use some other algorithms? Uh, with train test split, let's try the logarithmic part. Okay, with train test split. So let's control C, control V. What I'll do here, I will write here log reg, and then just log reg equal to logistic regression, get max equal to 100. Okay, log reg dot fit x string y string, then y pred kn. This is log reg. Log reg dot predict x test, print matrix y test y predict. Let's run this. So 97%. Okay. Now the final conclusion thing. Before concluding, I want to show you one thing. Uh, what is the best value of k, or how I decide what should I use for k, 1 or should I use 5? Okay, so let's do something. Let's check what value of k should I use, which is the most accurate value of k. So let me assign some k value. Let the system decide from say 1 to 30. The system will decide any value of k. Okay, and then I will this is scores equal to this. I will store the result in a list called scores, which is empty at the moment. And now let's run this for k in k range. Okay, so what is k range? K range is range from 1 to 31, 1, 2, 3, 4, 5, 6, 7, 8. So 1 to 30. And what is k? K is 1, then k is 2, then k is 3. This is nothing but for loop. Okay. Now, what I'm doing here, I'm just test this thing, control C, and paste it here. But now I will not give anything on my own. I'll put k here. So k can be 1, k can be 2, k can be 3, k can be 4, k can be anything. And then I will append this. I will append this scores, this result. I will what I'll do. I'll append the accuracy. What this accuracy is. I'll append that in my scores list. So this y test, y predict accuracy. I will add this value every time for every value of k to this scores list, and then let's print the score. Okay, so I'm getting 97, 97 every time. Okay, no problem. And if you see, if you print the mean, I think it here. If you print it in other line, print. They need to print this thing. Print this thing. Control C, Control V dot mean. Okay. The mean is 97%. with brackets are right. Okay. One bracket. Sorry. Int matrix dot accuracy y test. I don't need this one. I need this one. Now it is okay. 97 bracket mismatching. Now let's plot this thing and see what value of k should I take. Okay, let's plot this thing in using my matplotlib. Import matplotlib dot pyplot as plt. Again, this is alias. You can write anything in place of plt, and let's plot this thing. So plt dot plot. What I need to plot? I need to plot k range. So k underscore range, that is 1 to 30, and then scores, k range and scores, and then plt dot x label, x label, and then let's think for this is just labeling of graph. You can write whatever thing you want to be displayed on the graph. So different values of k, and then plt dot y label, and again testing accuracy. So now let's see if it is working correctly. Let's okay. Now it is showing that uh, for any value of k, it is showing that for any value of k at this point, 98% is the correct number. So I'm getting the mean, and you can check here also. You can check that 97.7% I'm getting, whether it is k is 1, k is anything. So from 1 to 30, if I'm using any value of k, the accuracy will be around 98%. Okay, so this is good. This is a good model. So you can use now from this thing. If there was some variation, so if there was some variation, then what you need to check? You need to check the highest value, where you are getting the maximum number of accuracy, and that will be your value of k, which you can put while using here. Maybe it can be 30, it can be 11, it can be anything. Okay, so I think this thing is clear to everyone. Okay, and what is the time? Okay, so I hope whatever we learned today, it is quite helpful. Maybe you know many of these things. You must have seen these things on YouTube or other else also. I found these things very helpful when you are starting data science. Uh, these things are the most important, most basic things which you must know, because you see here, if you are using sklearn, if you are familiar with superficial knowledge of machine learning terms, even you don't know what is linear, what is logistic regression, what is KNN, then also even if you remember the syntaxes, you can just go in. But uh, even if you see the name is logistic regression, it is not used for regression analysis. It is used for classification analysis. Okay, so these are the basic things. You don't need to jump into theory part uh, if you don't want to go deep. You can call yourself data scientist by learning these syntaxes. But if you are applying for some data scientist position in some reputed organization, in some reputed companies, then yesterday I show you what is the purpose of advertising data set, how you can help your company to just check whether they are investing in right direction or not. That is the purpose of data scientist actually. So because you see, all these things can be done with some hard work even on Excel also. Okay, just apply some filters and get some good values, plot. All these plottings are equally applicable on Excel also. Then why we are just involving our time and getting so much complex algorithms just to make my machine more and more accurate? Finally, that is a machine. Okay, the real control lies in the hands of human beings. So if you have to become a good data scientist, you just need to uh, concentrate on the theory part more, and that will come with more and more practice. Okay, so with this thing, I think I can conclude. If anybody has any question, they can put it forward. If there is a question, please let me know. You can type it in WhatsApp group also if there is a problem. Let me check. Okay. Okay, one question I have got here in personal. Okay, okay. The question is, I am not from computer science branch. Okay, good question it is. I am not from computer science branch. Can I apply for? Can I go for data science? So I am also not from computer science branch. I am from electronics branch. And in fact, if you check on internet, it shows that more than 60% of data scientists in world do not belong to computer science branch. And in fact, in this modern world, you need to be an object. Okay, you need to be an object. You can have list, you can have a string within yourself. Then only this is such a competitive world, because now branch don't matter. Computer science branch also works with Raspberry Pi, and electronics branch, electrical branch. Every branch works with Raspberry Pi, and that Raspberry Pi thing is actually an electronic device. Okay, so there is no foundation of any branch. Obviously, if you are a computer science graduate, you are in constant touch with programming. That is the only advantage. Other than if you are not in that branch, then you have to spare some extra time for programming. I don't think other than that there is no advantage of being which branch you belong to. Okay. Okay, with that, I think I can conclude now. I will provide with the data set in the WhatsApp group, and if there is any query, you can type it in person to me later also. You can email to me, or you can type it in group. I'll try to uh, solve that query for you. So thank you. I hope the session was knowledgeable, entertaining, and you learned something new. Okay. So with this, let me stop the recording and stop.